Hello, I am Osama Almurshed. I am a PhD student at Cardiff University. Today, I would like to talk about functional programming with Parsl. Functional programming approach allows users to focus more on the data transformation rather than the steps that forms the algorithm. Functional programming languages or functional programming in general will have less procedural syntax, and Python allow users to use it with other programming approaches such as procedural and object-oriented. There are three concepts in functional programming language, or main concepts. The first one is treating function as variable. The other one is higher order functions, which is creating a new function on the fly from a previous function definition. For example, if you have function, you will have function that will accept another function and generate new function. Another thing is functions pipeline, which is if you have a set of functions, each function output will be the input of the other function. Why we should use functional programming with Parsl? Because Parsl use a higher order function to perform the deployment in remote locations or machines. For example, here, this is two equivalent syntax that uses Python app function, which will take any function and make it distributed. And you can specify the location that you want to pass this function to or run this function to. This statement will return a function that we will use as a variable here. What problem we can solve with this approach? We simply can separate the application from the management. For example, here we can create application workflow like this one in graph form. This can be a simple distributed software, or maybe a more distributed AI application like neural network, where each layer can be a node in a graph, and with Parsl we can distribute it over a given infrastructure. Another thing is that we can create a customized, say, deployer or operator. The idea here is we can use Python app of Parsl to and extend it, adding more features such as monitoring or fault tolerance, load balancing, or simple deployment. We have two types of functions here, which is utility function and application function. These are examples of utility functions, and this is an example of an application function. Usually, utility function will accept application functions and their argument, and during the call of the utility function, it will try to manage the deployment of the application function. Utility function functions. These are two examples of utility functions. The first one here is will perform simple deployment, function deployment. It will take any Python object, a function here, then will map it to or deploy it to a specific location. It uses Python app to create the Python app on the fly. Then after that, it will call the function here. This is a more complex example, which will take the placement function or any placement function, then we'll measure the time of the deployment of that function. This is gonna be run on a separate thread because it is a Python app, which will use thread pool executor to perform the operation. This is an example of workflow application that we can create. It has three main application functions. It does arithmetic operation like adding or maybe doubling and tripling. This is the workflow definition. This data model is Python list, which can ensure the workflow will be executed in this order. In this example, the adding function will pass its output to the doubling function, and so on. We can take this function and a variable or list of functions and pass it to a utility function to do the deployment. This is a utility function that performs round-robin load balancing. It will take the workflow, any workflow, which is a list or data model that holds a set of functions and its dependency, and a set of locations, which is the computing resources, and finally the placement function, which will take the current location or the resources, map it to a specific function, and pass the input to it. This is the algorithm for the round robin. Finally, we can use functional programming language to separate the management from the application, which will give users more flexible way to write their application without concerning about the management, and when they want to develop another operator in the management, they can do it separately. Thank you for your listening.
Questions? Okay, Sam, I have a quick question. Are you doing that round robin scheduler to try and distribute functions across a bunch of devices? Is that the goal here?
Yeah, exactly.
So you're basically working around the limitation of Parsl, where if you specify a bunch of executors, it's not clear how the distribution actually happens.
Yeah, I'm trying to solve the problem of deciding where to place a specific function to a specific resource. Yeah.
All right, neat stuff. Thanks.
Thank you. Thanks.
Okay.